All right, midterm practical. I'm gonna go through the exam. We had a few common cars done. The darts, the GMC, the G8. We will look at the specs for all of those and see how they actually test. Let's start with a black dart. Yeah. So to begin, identify co-cranking amps of battery, perform a good visual inspection. What is its general condition? So, looking at the battery itself, really nice and clean. Battery's tight. Terminal's good. Terminal's good. Looks nice and clean. Cold cranking amps. Cold cranking amps, 650. Before we do that, we have to do a case drain and an open circuit voltage test to make sure it's good enough to do a heavy load. Meter set to DC volts. One on common. One on power. So there we have 12.45 volts. Again, we want to be between 12.4 and 12.6. If we're going to do a heavy load test, that would be 75 to 100% charged. Basic case drain test. So my meter, we can kind of see them. I'm going to run my lead around my case. 0.14. Pretty darn clean. Black dart, very little case drain. So back to my lab. Now I'm performing a battery load test. What amperage am I going to load the battery to? 325. It's a 650 cold cranking amp battery. We're going to load it to half our cold cranking amps. If it was an amp hour, we would do it 3 times our amp hour rating. But I do believe all the cars we had in here were cold cranking amp rated. My battery connections. Positive, negative battery. That connection never changes. Meter lead out of there. These darts have a lot going on in the positive post. And be careful exactly where we attach it. My bat tester shows that 12.4 volts that we were looking at. Showing 0 amps. If it did not, if it said something other than 0 amps, we would want to go through and zero my meter out. We need to worry about that. Zero it anyway. Now the goal is we're going to load it to half of our cold cranking amp rating for 15 seconds. At the end of 15 seconds, we need to have 9.6 volts or better for it to be considered a pass for a heavy load test. It was really close to that. It's probably fine. We could probably recharge it, have it actually pass, but we'd like to see it right around 9.6 volts. Now we're going to measure the current. We need to use our current probe. This guy changes positions with every test. This needs to be where current is flowing. Every circuit you're testing on this, you're testing in series. Therefore, you can hook it in the circuit anywhere as long as you're in the circuit with a load. For our battery heavy load test, this guy is our load. Okay? Our big heating element, our 2 big positive battery cables. If we want to see the amount of current going through that heater assembly, my inductive clamp can be around either the positive or the negative tester cable. It doesn't matter. Amperage is amperage in series. So we'll pick one. We just can't be around both. Again, check my ammeter. We're still zeroed. So let's try to pull 325 amps on the black dart and see where we end up. This one's nice. It'll count for me. I can freeze the information on the screen. So we'll try to do that. my black dart failed a heavy load test at 12.4 volts. We had a few different test results on this one, depending on where the battery was when you started. Few people had it just barely pass. This is a fail, but that's the process for my battery heavy load. So I can go to my lab sheet, battery heavy load test, amperage 325, how long? 15 seconds. Battery load results, my amperage was, well, we were pretty close to 315, 325. Voltage at that point was 6.6 volts. Did it pass my load test? No. So this test, black dart, did not pass. Gray dart, open circuit voltage, could use a DVOM, however it's 12.5 volts. Digital tester is good enough, so open circuit voltage is high enough to do a heavy load test. Battery itself looks relatively clean. We do have a little bit of dirt on it, so I am going to do a little bit of case drain test on it. Negative, my positive lead, across my case. Not bad. So all in all, case drain looks pretty good. We know we're good enough to do a battery heavy load test. Again, 650 amps. That's my cold cranking amp rating on this one. So we'll load it at 325. Then my VAT tester, we'll load them at 325. See what we have for voltage after 15 seconds. Try to freeze everything on the screen for us. See how this works. Remember, your VAT tester is your load. You need your inductive clamp. Positive, negative, doesn't matter. We want to see the amperage in the circuit we're loading down. Now that we have that, let's see what we're doing. Load them to 3. Man, this is jerky all over the place. Alright, so we're at 8.8 volts at 353 amps. I overloaded it a little bit, I won't lie. These testers are really hard to keep really smooth. This guy, the voltage stayed high enough for so long, I would probably recharge it and retest it. But technically at 8.8 volts, that is a fail for my gray dart. The blue GMC, the battery was a little more of a pain to get to, but still very accessible. So we'll look VAT tester up. So 12.4 volts, 680. So we're gonna load it down to 340. 340 amps at 12.4 volts. We'll see how this battery does. A little more. So we end up with 9.3 volts. Just trying to keep it right around 340. Again, really touchy on these things. Overall voltage is 9.3 volts. We started with the battery right at the very bottom of our testable scale. I would probably recharge this and retest it. We are really close to passing. It was a dead failure. We saw 7 volts, 6 volts, what have you. We can condemn it, no problem whatsoever. We have 9.3 volts available when we should have 9.6. Boy, that's worth retesting and recharging. Part 2, starting systems. Again, you all use the same vehicles you did battery tests on. Year, make, and model, not that terribly important. Were you disabled to perform this test? Most vehicles were clear flood. A few folks did disconnect coil packs or fuel pump relays. That's fine, I'm good with that. However, clear flood did work on all the cars that were in our lab. So, what are you disabled to perform this test? May have been coils, may have been fuel, it may have been clear flood mode. So, that's what we would have answered. What are my starter amp draw results? Now we're using the starter as our load. Our starter is buried way back there under the intake manifold. Not easy to get to. However, it doesn't matter. The starter is a series circuit, like we were talking about. We can measure on the power side, the ground side. We just have to have all the wires on the positive or all the wires in the negative if we want an accurate test result. So my battery connection stays the same, that never changes. My inductive clamp has to change for each test. So now that my starter motor is my load, I could crawl into the car trying to find the starter, hook this on the wire for it, but all of that energy has to go back to my battery. We have got a whole bunch of positive connectors. That's going to be a pain. On the negative side, we have one ground wire. That will be pretty easy for me to hook my inductive clamp around. That way I can see all the current going to my starter motor. So now let's crank it over and see what we get. So we can see my battery has recovered a little bit. Since battery voltage is a little bit low, we're going to expect a little bit higher than normal cranking current. These guys, the darts, are kind of power hungry anyway. We really should have that, approximate 25 amps per cylinder. 4-cylinder like this, we would expect to be maybe 100, 125 amps. Let's see where we end up. Okay, most people were measuring somewhere 175 to 190 amps for cranking current. A little higher than we would expect for a 4-cylinder. Again, battery voltage is a little bit low. Even with good battery voltage, we were running about 170 amps. So this one is a little power hungry. So for my lab, what do we disable? Clear flood. What was starter draw results? Amperage about 175 to 190. My voltage, we were right around about 10.6, 10.7 volts. Is it within spec? No. Did it pass? No, not really. We would probably want to recharge and retest. So, is it within specs? Technically, no, it is not within specs on the black dart. Then your lab asks for general amp draw results for 4, 6, and 8-cylinder. Again, 25 amps per cylinder, plus or minus about 25 amps. That's about where we want to live with a lot of these. Some are a little bit higher, some are a little bit lower. If you're unsure and it looks like, wow, that's way more, way less than it should be, look it up. All those specs are published. Go to specifications for that vehicle. They'll be in there. You can look them up that way. But 25 amps per cylinder is a pretty good general knowledge for amp draw. So 100, maybe 125, 6-cylinder 150, maybe 175, 8-cylinder might be 175 to 225. Again, they're all a little bit different. They should be in about that range. Two causes of lower than normal amp draw. Lower than normal amp draw means the starter motor is spinning faster than we expect it to. So we may have internal engine damage, we may have a broken timing belt, we may have low compression, we may have starters where they're not engaging into the engine and they're freewheel spinning a little bit. That would typically cause lower than normal current draw. Now realistically, that's not the problem we usually have. Usually it ends up being excessive current draw, and in that case, this two causes for higher than normal current draw. We could have bad starter motors, burned up brushes, internal engine problems. Low battery voltage causes high current flow. Anything that's going to cause that starter motor to spin over slower than normal will cause higher than normal current flow. So that's how we should have answered that or looked at it. Black dart. Starting system gray dart. Verify he is closed all the way. He is. Let's see if we get cranking current. Again, these starters are a little bit power hungry. Look at the floor. Clear flood. So it's 170 to 190 amps at about 10.345 volts. Voltage is fine. Amperage is a little bit high. Again, these are power hungry starters. We looked them up. They actually say these things should be 150 to 175 amps. So we're right in that range for these starter motors, even though we really expect it to be lower than that. So that's starter amperage on my Grey Dart. Now to make my life a little bit easier for starting and charging, took the VAT tester off the cart, put it up here by the windshield so you can see it. Clear flood. Let's check out green current. So maybe 190 on the high side, but 156 on the low side. Faster crank, the better the current got. Voltage was well within allowable limits, between 10 and 11 volts. So cranking current looks perfectly normal on the blue Chevy truck. So the last part of your test there, charging systems. Perform a charging system maximum output test or maximum amperage test. What is the maximum amperage recorded? Then perform a diode test, and what are my results? Let's do that. So on this Dart, again, positive, negative does not change on the battery. We're going to leave them there. Now, my alternator is right there. It's relatively easy to get to. I can get right to the power output wire for it. We can kind of see it up in there. It's kind of foil wrapped. So I'm going to put my inductive clamp on that guy. Now, if he was buried and really hard to get to, all of the energy that alternator is producing is going to my battery. It's a series circuit. So I could actually take this clamp, go to my negative or my positive battery posts, and get my amperage there. However, I kind of like going right to my source. You know, it's as accurate as I can possibly make it. A few people, well, I watched them test. A few people did not move the probe like they should have. For some of them, a bigger problem or another problem that showed up was a lot of people weren't ensuring that the clamp was closed all the way. We really need that clamp closed for it to accurately measure current flow. So, still all hooked up. My VAT tester. Now the hard part about this is I'm going to run him at a higher PM and load him down. This is a mistake a lot of people made. They hooked it all up right, everything was good. They had me go in, start the vehicle, run at a higher PM. They saw what the amperage was while it was at a higher PM. That's the amperage they used for their maximum output. In order to see actual maximum output, we have to load that battery down while we're charging. So remember, we want to load the battery down so the alternator thinks battery voltage is lower than it should be, and it's going to give us everything it has trying to charge the battery back up. In order to do that, I'm going to find a way to run this guy close enough. Alright, so I'm going to start him up, run him at a higher PM. While I'm doing that, I'm going to load my battery voltage down. Remember, if we pull the voltage too low, we're removing the power from the alternator for it to make power. So we can't pull it terribly low, but we want it low enough so that the alternator has to give us everything it has. So let's find out. Start them up. You can see right away we went to 150, 140 amps. That battery is pretty low. Its goal is to charge that battery back up as fast as it can after startup. So let's see what the alternator can actually give us. So it's a maximum of 160 amps. If we want to test diodes, we can do it this way. Diode good, so less than half a volt. AC, we could use the DVOM also. There's nothing wrong with using a DVOM and measuring the AC voltage right at the alternator. That's what our tester is doing here for us. So, black dart, 160 amps. So going back to my lab sheet, maximum amperage recorded, 160 amps, 161. Performed diode test. Results, tested good. Did use a DVOM or a VAT40 to check the diodes. We used the VAT40. What's considered acceptable AC voltage? Again, nothing more than half a volt we ever want to see coming out of my charging system. And that's half a volt AC voltage. What does Amper expect for the vehicle? We'll look that up here. If we did have excessive AC voltage, what's the most likely cause? In that case, really we're probably looking at a rectifier diode failure. That's what's going to cause negative voltage. And again, we can pass that information on to the customer so they truly understand that you know what's going on. Black dart. If we look at specs, we were charging 162 amps. Nominal rating is 140 for this alternator, so we're well within its allowable range. Remember, it's plus or minus 10%, so 155 wouldn't be abnormally high, but we're well within amperage spec for my Dodge Dart. So same thing, high RPM, we're going to load the battery down, bake the alternator into thinking battery voltage is lower than it should be, and we're going to see just how strong it really is. Alright, start. There's our data. You can see them coming up and charging real quick. So let's give them a little load. $160 amps. So let's go ahead and do a meter diode check on the gray dart. Black meter lead ground. Red meter lead. Alternator output. About 0.03 volts. We are well under the 0.5 volts. We need to make sure we don't have. There's no AC voltage problem in this car. Everything looks good. Some inductive clamp changes position again. Alternator output. That big dude right there. And make sure our clamp's closed. Make sure we're away from all of our belts. It's good. Silverado has somewhere between a 100 amp alternator and a 130 amp alternator, depending whether it's a Bosch or a base alternator. Now remember, it spec said 100 to 120 amp for my alternator. Let's see. Run them at a higher RPM. Again, the amperage goes way up. We're trying to charge. Right there, I'm pretty sure we have more than a 100 amp alternator because we're charging 130 amps just sitting here. Doing everything I can to charge that battery back up. So now, if I can load it and rev at the same time, let's see. We see that probably. RPM. And diode check. Diodes are good. That's the Blue GMC. That's enough. Hope you did well.